Okay, so just a little bit on the limit laws, guys. Hi, this is Mrs. Allen, and I want to talk about calculating limits using the limit laws. Suppose that c is a number and f of x and g of x are two functions whose limits exist at the number a. That is, the limit as x approaches a of f of x and the limit approaches as x approaches a of g of x both exist. Then the following properties of limits are true. So if you look at the first one, the limit of a constant, this idea is that a constant always remains the same. So if we say something like this, with each one of these I'm going to try to give you a little example. The limit as x approaches 5 of the constant 2. Well, that doesn't change 2 at all when x approaches 5, so it's just going to be 2. Okay? For the next one, if we would say the limit as x approaches, then say 5, of just the variable x, well, x is now changing. What is x approaching? Well, that value is approaching 5. Then if we have the limit, say when I talked about this constant, this idea of pulling the constant out front, though you may not have to do that. If I have the limit as x approaches 5 of 7x, so 7 times what x is, we could then take the constant out front, 7 times the limit as x approaches 5, which would then be O of x, and of x. Then it's going to be 7 times 5, which is 35. So you could do a direct substitution with 7x, or you could take a look at it and see, well, we could do a direct substitution here, 7 times 5. So either way. The point is that sometimes we want to pull this constant out front, and it's very handy to, especially when it makes the expressions a little bit easier, little smaller numbers and so forth. Okay, so now if we have the limit of a sum, it's equal to the sum of the limits. So if I have something like the following, if I have the limit as x approaches 5 of 7x plus 5, then that's equal to the limit as x approaches 5 of 7x plus the limit as x approaches 5 of the number 5. Okay, so we get this is equal to, the limit is, then we already know this is 35, and we know that this is then just going to be 5. I think I had a 2 there, but that's all right if we leave a 5. So then we have this is equal to 40. So if we use a difference, that would be very similar. So if we had 7x, the limit as x approaches 5 of 7x minus 2. It would be equal to the limit as x approaches 5 of 7x plus the limit as x approaches 5 of the number 2. Oh, minus. Yep, here. Too close to the board here. That's a minus. So then we end up with this is equal to 35 minus 2, which would then be 33. So we have 33 for our limit answer with the difference. So there are times, like I said, this is just using a very simple function to be able to illustrate the rule, but there are times where we want to separate the limits. So for the product, so the limit of a product is equal to the product of the limits. So for this one, if I gave you something like this, if I said the limit as x approaches 5 of 7x minus 2 times 7x plus 2, and again, there are a lot of different things that we could do with this limit, then this would be equal to the limit as x approaches 5 of 7x minus 2 times the limit as x approaches 5 of 7x plus 2. So in this particular case, you can see that we would get the limit as x approaches 5 of 7x minus 2. We could do this whole thing and break it down, but I'm just going to say that it's 33 right now. 33 times, and the limit as x approaches 5 what do I have, 7x plus 2? So that's 37. So in multiplying those together, we would get a product of 122? No, 1,221. That should be right. Call me if I'm not right, or email me. That should be all right. So now, again, the point is here that you can take the limit of a product and you can split it up and make the product of the limits. So there's the product. And then if I have something like the limit for number 7, if I have the limit as x approaches 5 of, say, x, and I have that this is cubed, an expression like that, well then you can say the limit as x approaches 5, since you've got to take it around the whole argument of just x cubed. So we can clearly see that that's 125 by doing a direct substitution, or 5 cubed. And then the last problem, if we have the limit of a quotient, for number 8, we have the limit of a quotient is equal to the quotient of the limit. So how about if I give you this one, the limit as x approaches 5, it's like 5 of x squared plus 7x plus 1 over x minus 3. Then that's equal to the limit as x approaches 5 of x squared plus 7x plus 1 over, all over the limit as x approaches 5 of x minus 3. Okay, though it is not necessary to do this, again, we're showing you with simple functions how this works. So it would just be 5 squared plus 7 times 5 plus 1 over 5 minus 3 in the bottom. So our total result would be 61 over 2. Okay, and then there were a couple other problems that I wanted to discuss with polynomials, and yeah, we can get to those tomorrow. And you guys have a great night. I'll talk to you tomorrow. Take care.